Alright, looks like we're live. Okay, so off stream I'm trying out like how to return the pointer to an array of specific size. Okay, let me show you. Basically something like this. So in the previous session we learned that we can hold on a minute. Okay. In the previous session we learned that we can take the address of string literal, and it seems like, well, I don't really know what's going on either at the moment, so it seems like it have a different type, So if I understand this correctly, we have a pointer to an array with size 4. I mean, this is 4 because, like 0, A, B, D, and null terminator, right? So if I can explain this, is like we have array of char characters for characters, and we take the memory address of this array of 4 characters, like this memory address of array of 4 character. As far as I understand, it is something like this. So we have array of 4 characters, and we took the, what is it called? The entire array of 4 characters memory address, and then passing that to this confusion variable. Right? But yeah, I'm still not really sure why it become like, why this become like a 2-dimensional array, something like that. So yeah, so on off stream I'm trying out this mechanism, like how to make a pointer how to create a function that return to a pointer of array with size 4, maybe something like this, array with size 4. And again, this is basically means C, E, F, and then null terminator, right? So yeah, again, this is another confusion. Okay, if anyone knows like why this confusion variable becomes something like a two-dimensional array, please let me know. Okay, anyway, let's continue. No, not this one. I think this one, right? Oh, right. I also update the wait a minute. I also update, what is it called? The explanation for why I didn't use malloc and strcpy. Well, it's basically because we are using, or I am using string literal for this, what is it called? Alpha underscore r function, right? I'm using string literal, and string literal have a static storage. I guess it is like, what is it called? Like static variable, So it will persist the entire execution of the program. But then again, I'm still not sure, like what is maybe the difference. As far as I understand, even though it is static storage duration, it is not saved in the .data or .pss. Let me check in here. Right. So yeah, I'm not sure if string literal will affect the executable size. Like for example, let me check, what is it called? PSS playground. I think this one. Yeah, maybe this one. Okay, and then one. Okay, right. If we can see, maybe something like this. As we can see, the size is different, and the 3 megabyte in here is actually something like this. We have, what is it called? B as an array of integer with size 1 million, and we assign an initial value like 69, and well, the rest is basically just zero value, right? When we compile that, and it looks like that initialization at what is it? Adding some extra size or the point is that adding the initialization like this for the global or the static variable will have an effect that increase the executable file size. So yeah, that is interesting. But then again, I'm still not sure if the string literal in here will have an effect to the file size executable, Like maybe having a lot of string literal will increase the executable significantly. Maybe I still have no idea. Maybe we will check that out later on. But for now, I think let's continue first. Sun pointer, right? Okay, the listen printing. file copy. Okay. Okay. Right, previously I'm confused. What should I use as the... I'm not really confused, I guess. I haven't decided which variable name should I use. Copy, okay. Should I use this as Ori for original, I guess? And then, okay, let's put this in here. Struct alpha copy. Struct alpha Ori. Right. And then we use malloc to allocate the memory for us. Struct alpha value equal malloc size of not Ori value, right? Okay, and then okay. We put that X type, V type. Okay. Set the value type, right? Equal Ori type. And then switch. You know what? Maybe we can replace this using the X type, right? I mean, we are assigning this V type to X type. Okay, I think that should be fine. Again, I don't really want to... what is it called? I don't really want to follow the book as is, you know. I want to add some difference, I guess. Wait, what? Okay, I hope my internet connection is fine. Let's see. Okay, case alpha fun first, function and numbers directly. Okay. Right. And then of course break directly. Okay. Value fun. I think it was fun, right? Yep, value fun. Fang, right? Alpha, num, okay. Don't forget to break. Value num. Ori num. Alpha. Error, okay. I don't think I need to copy that. So let's just do it like this, right? Ori error. Symbol. Well, I guess this is the tricky one. Like previously in the alpha symbol, I also didn't use malloc because the character for the symbol will be available until we call this mpci state delete in the main function. So I can be sure that the memory address that we are passing from the sim function parameter to the sim in here, right, it still exists, at least until we call mpci state delete, which basically we free the abstract syntax tree symbol, right? So I'm not sure if we are gonna change this like using malloc, because maybe we will put this in the evaluation, maybe, yeah, I'm not sure. Okay, at least for now, we can just copy that sim, right, and then don't forget break. Copy list by copying its sub-expression. Okay. If I remember correctly, that looks like something from this. Oh no, maybe the add function here. No. Where did I use that? No, not copy print. I don't think we use the same thing. Oh, in there, when we are deleting or freeing the memory allocation. Okay. This looks kind of the same. No, not really. Not really the same. Okay, anyway, let me. Okay. this alpha symbolic expression, and then right, we can do this in value count. We are passing the count from the ori count and then cell. Okay, value cell ori cell, no. Okay. Okay, malloc here, size of value cell, then something like this. Okay, value cell, oh, time x count. Yeah, the multiplication might cause some problem. Well, okay. What is it? Real log? Guess. What is the equivalent real log array? I guess we don't need to check this. Because we already checked the value count. If the value count, yeah, but maybe we will handle that later on. So value count. Yeah, there is a chance that this will overflow. Let me add a to-do, I guess. Possible integer with multiplication. And then we, what is it called again? If value cell null, right? Alpha L, yep. if malloc cannot allocate the specified size, malloc will return null. So if it is null, return malloc error. Okay, and then value type, no, not value type. Okay, so we are using looping to fill out this cell. Okay, another recursion. Okay, I mean, recursion can be hard to debug, you know. So hello Omar, welcome. I don't really understand what you're typing, but anyway, welcome. I'm currently on the chapter 11 of this book, Build Your Own Lisp. Let me copy this. Let's go keep practicing coding. Yeah, let's go. Let's learn together, you know. It is interesting. We are currently in chapter 11. And what is it called? What is it? This one. I'm trying to implement the copy mechanism. Oh, basically, as far as I understand, the chapter 11, we are trying to implement variable. Basically, we are saving a value with a label. Is that where the variable names came from? I'm not really sure. But yeah, we are kind of adding a label to the value, right? Naming value. So we need some kind of environment for that. I'm still not sure what environment in here means. What is a Lisp? Okay. Lisp is another programming language. Let me wait. Oh, am I lagging? Lisp is another programming language. Let me copy this in the chat. So if you know about Python, let me demonstrate that. In Python we can do something like this, right? And what we are creating is something like this, or maybe to be precise, like this. This is the Lisp syntax, and well, Python is something like this. So we are kind of trying to create a simple interpreter, a simple programming language, I guess. So yeah, that's the goal. That's the goal of the project, but well, the goal is to learn C. So we are kind of learning C, the programming language, but also learning Lisp, another programming language. Yeah, it is interesting. So we are learning programming language by building another programming language. Okay, but yeah, the point is still learning C as the programming language, right? So we are just creating a simple implementation of Lisp programming language. Okay. Let me continue first. Where is it? It's in this one, right? Integer I equal 0. Oh no, let's put this in here, I guess, or maybe putting this in here, right? Okay, equal 0. I mean, this is subjective preference, and then e less than value count plus plus or plus plus I guess. Just basically the same thing, and then value. Okay, currently I'm practicing that language to get web and mobile app, but the core is the same. You need to understand the logic behind it. Oh yes, I mean, what is it called? Programming language has their own mechanism, right? But it's just a matter of syntax and all of those stuff. The point is that we need to know what we want to do, I guess, right? What we want to achieve with this programming language, right? So yeah, the logic is still the same. It's just a matter of the syntax, right? And how those programming language doing things. For example, like the asynchronous mechanism in, I guess, in JavaScript and in Golang is quite different. So I'm still not sure what the difference, right? But I've heard some people saying that the mechanism is different. So, and maybe in Python too, right? The asynchronous in Python can be different with another programming language. So that might be some consideration too. But the point is still the same. We need to know how to create an instruction in this programming language, right? When you're writing different value from the user, also I'm working as a data analyst and I develop several apps with Power Apps, and that syntax is really friendly, but you need to understand and make a clear distinction. Okay, when you are writing different value from the user, right? Right. We need to make a clear distinction. But yeah, the point is we need to understand what we want to achieve and how to make that readable for another programmer, I guess. Some people even say that we are creating the source code for another human. For another human first rather than for the machine first. Maybe they are right, you know. I mean, the one who read the source code is another human or my future self, right? The machine only reading the machine code. Well, have a good day too, Omar. I'm going to say, have a nice sleep. See you next time. Value cell. Alright, keep practicing. Okay. L copy. Oh, okay. I hide because of this. Alpha copy. Okay. Value cell. Okay. The recursive mechanism can be difficult to debug later on, So let's hope for the best. Okay. And then, right, don't forget about the break. Okay. Value. Okay, malloc. Okay. And then we are break. Okay. Should we add a default? I mean, in this case, I didn't give a default because at the end of the day, it's just freeing the memory, right? But in this case, we might need a default. How many switch cases do we have in here? This is for the file copy, okay. See, default, right? Del, okay. Let's add the default. Oh, yeah, and we can add the default at the start of the switch case too. But in this case, don't forget to add the break. What is it? The break statement? Something like that. If you want to add the default at the... What is it? At the beginning of the switch statement. But I usually prefer at the end because we are having this case and then another case, right? And so on until, well, if we don't have any case, let's return the default value, something like that. So for me it feels natural, I guess. So, but yeah, your preference might vary. Printf unknown value type. Unknown. Unknown type. Or maybe return an error, like unknown symbol, okay. Unknown value type, okay. Unknown value type. And then return X. Return value. We replace X with value if I remember correctly. See, this is why I say to change the variable name, because we need to analyze what X in here translate to our implementation. No. Okay, alpha copy and then environment. Oh, must encode a list of relationship between names and value, right? The name is the label and value where the value. Must encode a list of relationship between names and value. There are many ways to build a structure that can do this sort of thing. We are going to go for the simplest possible method, okay? That works well. Alright. This is to use two lists of equal length. One is a list of alpha pointer and the other is a list of char pointer. Okay, that works well. Two lists of equal length. Two lists of equal length. Each entry in one list has a corresponding entry in the other list at the same position. The forward declared or okay. So we can define it as follow, right? In the header file, in my case, in my implementation, this one, the book said that this is forward declaration, but yeah, I'm not sure what is the term. Okay. And then we declare that, and then we give the struct body, I guess, later on. Okay, let's put it in this one. Oh, right, we use forward declaration like this so that we can use it in the type def here. See, there is this struct env pointer and struct alpha pointer. So I put this here. And yeah, this did seem confusing, but we are using this type alias, I guess, or type definition in the struct eval body. So I am still not sure how to explain that. Like, maybe it's like the planning, you know. We plan to have these two struct, right? And then we will we will define, I guess. So in this case, we declare the struct that we want to use later on, and later on we use the struct, right, like this, and then later on again the next step is we are defining what is the struct alpha. So maybe this is something like, what is it called? Something like the planning phase, and or maybe sketch. Maybe that's the word, I guess. This is the sketch, right? And And then when we want to to create the real thing, we define the struct like this. And hopefully that makes easier to understand. Again, like I'm still learning about the syntax of the C, so my explanation might be wrong, but at least that's what I'm thinking, right? We have this sketch for the planning, and then we have the execution for what we want to do with the sketch. Okay, maybe something like that. In count char. Okay. Oh, interesting. I mean, instruct pointer of pointer can also mean array of pointer, you know. I mean, array take k to, what is it called? Array take k to a pointer. Oh, right. In case anyone haven't seen, I make a blog post about this, the square bracket as the reference operator. So basically, when we are trying to access the index, wait a minute, or indexing, I guess, we are accessing the index. Do I have, oh, like this, right? This is also another form of the reference, which, I mean, this is my hypothesis, so I'm not really sure if this is correct or not. I mean, the decay point, the array decay to a pointer means that array is not a pointer, right? Because as far as I understand, a pointer can only store one memory address, and in array we can have multiple memory address. So maybe we can imagine, like, what is it, handling array like handling the memory address rather than the exact value. I guess this one, when we are dealing with array, so dealing with memory address as the value, right? Not the actual value. So even though we are dealing with the same memory address as a value, the similarity only, as far as I understand, in the reference operation. Okay, array can store more than one memory address, but pointer can only store one memory address at a time. Let me copy this in case if you want to read this. So yeah, that is why array is not a pointer, but can decay to become a pointer, you know, because array have multiple memory address and then suddenly decay into one memory address, as far as I understand. Okay. So yeah, this can also mean array of pointer, or maybe two-dimensional array, maybe. Yeah, this can mean a lot of things. It is quite tricky, right? Okay, we are going to go for the simplest possible method. This is to use two lists of equal length. One is a list of alpha, okay. If I forward declare, okay, now we are defining this same. Okay. If we are using sims, it looks like it is a pointer of pointer, because in here sims is a pointer to char. A char pointer or pointer char, whatever you name it. Okay, alpha, struct alpha false. Let's just use values and sims. Okay, first thing first, let me be part of. Okay, right. We cannot have, what is it called? We cannot have a declaration inside of the label, as far as I know. Only part of a statement, and a declaration is not a statement. See, a label can only have a statement, and declaration is not a statement. Okay, I mean, I'm not sure if we can run this. Okay, we can. But yeah, to make things not biting us, let's run. Let's follow the warning as much as possible. Return failure. Okay, let's take a break for a moment. Let me go to the toilet for a bit. Be right back. Okay, well, I know we are in the break session, but well, let's continue. Okay, we need some function to create and delete the structure. We need to create and delete the structure. Okay. This is new, and then this is delete. Right, we need to free the child of the sim in the symbol, right? Okay. Yeah, so this means what is it? Array of pointer, I guess. Okay. Where should I add that? Maybe in this one, alpha. Okay. Oh, sorry, it should be like this. Anything new or create? There is add and there is read. Okay. Maybe call it initialize, Do I have a similar like where is it? I remember that there is something. Oh, is it in here? Like, yeah, later on we will try handling the integer overflow again with multiplication operator. With multiplication operation. Right. I think where is the root? This one. Okay. Right. So we'll just call it a symbolic expression. Okay. Alright. Let's just call it init to initialize. It a void, okay. And then tell what is this, okay. Struct elf. Should I add the name of the parameter? I mean, that's okay. It works fine, right? This is valid for the function. What is it called? Function prototype. So yeah. Let's just call it value. I don't really have that much vocabulary, I guess. Init, value, fun. The classic, right? Copy, okay. Put this in here. And I guess this is why I like a split window. In the left side, I can have some reference, right? And then on the right, I can write the actual code. You know, it's just a personal preference. Okay, we have malloc again, and I think it kind of similar to, where is it? To this one, right? Okay, oh, well, yeah, this is having a empty parameter. I mean, I guess we can also use this, but the thing is that some compiler did not give any warning if this function prototype need to have a parameter or not. Yeah, as far as I understand, that's why there is this void parameter, right? Because if we write it something like this can also mean that the function lf init can take any argument. So to make things clear, we have this void. I mean, you can use another compiler other than GCC, you know, so this is just a safety measure, or at least make it consistent across compiler. Value size of value. And then we need to check if value null or not. If it is null, oh no, I found malloc R can only be for struct L file. Alright. Maybe we should, what is it called? Maybe we should use void pointer. Maybe we should use void, I guess. void. Okay. Let's put it like this. I mean, this is a valid syntax as far as I understand. Okay. Oh, so just spaces around empty body. A non-void function. Okay. Around empty. Alright. Well. E. In here, E. In my implementation, it is value. Okay. So value. What is it again? Let me check in here so that I didn't really, what is it called? I didn't really depend too much on the book. Sim with null, right? And then these values. Oh, value and then values. Interesting. Okay, and then return value, something like that. Oh, right. There is no guarantee that the count is start from 0. And yeah. Let's check. Okay. But it should be valid, right? Yeah. So put this in here. Or maybe something like this. We empty body. Oh, let me check. I'm kind of curious. Empty body, where is it? Warn if an empty body occurs in an if else. Okay. So if I'm doing something like this, okay, interesting. So there's a difference, or maybe like this. Okay, so this is a suggestion to use bracket or curly bracket instead of, okay, alright. And tell void tell, alright. Struct env and then what is it? Tell struct value. read the body. Okay. The function body. What should we tell it again? Or free to be precise, right? And to free this same array. Okay. File. Oh. And file tail. Okay. Right. In A equals 0, and then what is it again? Value count. Right. A plus plus or plus plus I. I'm just using plus plus in here just to be consistent, I guess. Maybe in the new project I will use plus plus I instead of I plus plus, but yeah, it's basically the same. We are discarding the value that this expression give. We are only using the side effect of this expression. That's why it looks the same. Free value same, and then I, and then other than 3 we use alpha tail for the values. Oh, rather than values, maybe I should call it should I call it false? Or maybe cells, right? What is Lisp value alpha stand for Lisp value. Maybe I can rename that to cell. Let me take a look. Okay. It's kind of the same. Maybe call it cell. Let's call it cell. I mean, this should also be called cells. So well, past mistake. There is cell and there is cells. The plural one. Anyway. And then we free the, what is it? The parent, I guess. Free value sim, not system. Sim, and then set. Then we also need to free the value itself. And as far as I know, free is just basically change the label of the memory from used to unused, something like that. Okay, next we can create two functions that either get values from the environment or put values into it. Two functions that either get values from the environment or put values into it. Values from the environment or put values into it. Okay. Wait a minute. If symbol is the variable name, right? If symbol is the variable name, then this one, well, let's call it cells, right? I mean, I really want to rename this to make this consistent, but yeah, maybe later on the refactor stuff. From the environment or put values into it. To get a value from the environment, we loop over all the items in the environment and check if the given symbol matches any stored string. If we find a match, we can return a copy of the stored value. Get a value from the environment, we loop over all the items in the environment and check if the given symbol match any of the stored string symbol, right? So the symbol here is the variable name, as far as I understand. Just any of the stored string. If we find a match, we can return a copy of the stored value. If no match is found, we should return an error. Okay. The function for putting new variables into the environment is a little bit more complex, right? New variable. So we are putting a new variable into the environment that we just create. First, we want to check if a variable with the same name already exists. Okay. If this is the case, we should replace its value with the new one. Alright. New. Replace its value with, so it is kind of mutable, I guess. So we are creating a mutable variable. Okay. To do this, we loop over all the existing variables in the environment and check their name. Check their name. If a match is found, we delete the value stored at the variable at the location and store the copy and store there in here means the location, right? And store at the location at that location and a copy of the input value. Okay, okay. If no existing value is found with that name, we need to allocate some more space to put it in. For this, we can use realloc, okay, and store a copy of L file and its name at the newly allocated location. Alright. Env underscore get. Okay. I'm tempted to change this to file. This is files and this is vars, like the variable name. You know, like having a different symbol and variable name, I guess. But yeah, let's name it cell. We are saving the value in the cell. That's basically it. We can interpret that like that, right? Struct struct value, and then what is k in here? That over all items in environment. Okay, what is k? Check if the start string matches the symbol string. If it does, return a copy of the value. Oh, okay. So it's like the target or the input, I guess. Wait, hold on. Return a copy of the value. Check if the string matches the symbol string. I mean, how do we check this again? Is there any example in here? Get, okay. Variable evaluation. Okay. Info. Okay. Alright. Info delete. Okay. Return X. So early return. Okay. But then again, this is the environment, right? This is the value. Okay, so maybe I'm kind of wrong, but instead of value, right? Maybe we should use env. Value env. Right? Okay. Env something like this, and then we change this to env. Okay, this one env, and I'm tempted to change that with false. Yeah. Cell false. Okay. Env struct value. value, greeting the function body, or define, I guess, define a function body, and then for okay, I mean, let's check. For e equals 0, count, right? V count e less than and V count, and then e plus. Oh, we have if. Alright. If string compare, okay. I have my own implementation of string GMP, so I will use that. Okay, what is it called again? Advice seems right for the symbolic. Right, because it is array of pointer, I guess. Okay, value sim. It needs to equal 0, and then return alpha copy and v file. If no symbol found, return error. Okay. So we only use one variable. Okay. I mean, in C we kind of can do this, right? Multiple declaration in one line, even though that can be confusing at times. Yeah, it is possible. Alpha error. Unbound symbol. Not really unbound. What is it? Parcel not found, I guess. Okay, let's use this. I'm kind of curious. Is it the variable name or not? Where is it? The example. Eval head, okay. Hello, unbound symbol. Oh, where is the variable implementation? Well, what does this mean, Ken? We are evaluating, right? Hold on a minute. Are we saving the variable name in this? In the symbol? Is that it? That is wild. Yeah, what does this mean? Returning a function. See, returning a function. That is wild. So this is plus, minus, and the rest of this symbol is actually the variable name. Is that it? I mean, I guess that's why we... Where is it? I guess that's why we changed the symbol to with this collection of character, I guess, and we can use more than one of this symbol. So I think we can declare a variable name like this. Because this is a valid character for our variable name, right? Oh my god, yeah. That is why I hold on into this verse to understand. I want to understand what is the implementation what is the implementation before I change this expression, and that is kind of wild. We can declare a function, a variable name with plus, but then again, let's try that out after I finish this chapter. Excuse me. Yeah, if my assumption is correct, that is wild. Treat over all items in environment. Okay, return an error. Symbol, invalid symbol, I guess. Invalid symbol. Thing like this. Put, so we are updating the variable value, right? Struct and and then put. Right, we need the environment and then the value, right? And then what is this for? Iterate over all items in environment. This is to see if variable already exists. Okay. For in, okay. Oh, to see if the variable already exists, alright. Where do we use this parameter? Where is it? K, E, K, E, E, K, E, okay. Again, another potential of integer overflow, I guess. We will handle that after we finish this chapter. Okay. At least I want to try. I mean, I'm not sure if I'm able to, but we will find that out later on. Alpha copy V, like, oh. Okay, we are checking if the variable already exists. Okay, if variable exists, delete item, replace the variable supplied by the user. Okay, so why do we need two parameter in here? Okay, right, the symbol. We are deleting, okay. Is there any example of the put? No, not alpha, sorry. LF put. LF at built-in. Oh. Okay. Function. Function, I mean, I'm not really sure. Is this the old value? Wait, but if that is the old value, alpha sim name, alpha function. Where is the alpha function? This one, function type. We should update all our relevant functions that work on I'll fail to deal correctly with this update. Okay. Oh, okay, to deal correctly with this update. Okay. So I assume that where is it? This one. This one is the old value and this one is the new value. And we return nothing, right? So yeah, copy this into the file. Okay, well, we have 4 minutes. Struct L file. Alt. Let's call it that. And maybe doing this one other than old new. This is the old value, this is the new value. And then right, don't forget semicolon. Well, I guess let's try implement. Wait, this is supposed to be void, okay. Oh, if this is the case, okay. Let's try to find this env underscore put function in another session. So I guess that's it for now. See you. Thank you for watching and see you next time. Bye bye.